Okay. So I think we are good to go.
Okay, sir.
Yes. Question 1 says that a thermometer, I want to read out the question from here. A thermometer is taken from a room where the temperature is 72 degrees Celsius to the outside where the temperature is 32 degrees Celsius. Now, before we move on, let me just ask you one fundamental question there. What do you think will happen to the temperature of that thermometer when you move it from where the temperature is 72 degrees to a place where the temperature is 32? What do you think will happen?
I know the thermometer should drop.
Very good. Very good. So invariably, you have been given, there will be temperature change, yes. So you have been given a term. Remember yesterday, when we look at decay or growth function, I told you that you can use it for, what do we call it now? Newton's law of cooling. The last thing we discussed.
Yes, sir.
I didn't give you Newton's law of cooling equation. So I'm going to give you now. So this is the Newton law of cooling equation. So I'll just say recall. So you can be writing because of the time limit that we have.
Okay, sir.
Recall the Newton law of cooling. Which is dy dx. But this time, because it has to do with temperature and time, so I'm going to use dt, capital T, dt, small t. Do you get that now? Where capital T stands for temperature, small t stands for time. Is that clear? So dt dt
Yes, sir.
equals minus k into t minus t ambient. T ambient. Now, what do I mean by T ambient? That is temperature of the surrounding, ambient temperature. Is that clear? Temperature of the surrounding, that is ambient temperature.
Yeah.
And that's T ambient. So this is the equation for the cooling, Newton law of cooling. Why do we take minus K? Remember yesterday in that model, we said if K is negative, it means decay. So because Newton's law of cooling is going to be decay, the temperature will be coming down. Is that clear? So this is for saying minus K. If you want to look at it as compound interest formula, that is growth, it will be K, not minus K in that case. So we now have a differential equation to solve now. So solve the above. So to solve the above, we are going to separate the variables. Do you understand that now? Solve the above by separation of variables. Sorry, please, let me halt the recording.
Okay.
So that will be dt over t minus t amp equals minus k dt.
dt.
Is that clear?
Okay.
So I will now integrate
Yes, sir.
now. Now, if you look at the denominator of this, so take integral of both sides. That will be integral of 1 over t minus t dt. Sorry, the capital T now equals integral of minus k dt. So I can differentiate, I can integrate this using integration of the form f prime over f. Is that clear? Because if you differentiate the denominator with respect to t,
yeah,
it's going to give you 1. And that's what you have in the numerator. So that condition is satisfied. So this will be ln absolute value of t minus t ambient equals minus kt plus c, where c is constant of integration. Is that clear? Now make t minus t ambient, t minus t amp equals e raised to power minus kt plus c, which will now be t minus t amp equals e raised to power minus kt times e raised to power c, which I can now write as t minus t amp equals a e raised to power minus kt. And of course, a will be e raised to power c. So this is the solution. This is the solution.
Oh.
Is that clear? Now,
yes, sir.
We now use the initial conditions given. So you can quickly write this. So when you're done, let me know. Equals a e raised to power minus kt. So that is what we have. Now the question now says, a thermometer is taken from a room where the temperature is 72 degrees to the outside where the temperature is 32 degrees. So change in temperature. That's A will now be equals to 72 minus 32 degrees. That will give us 40 degrees Celsius. So that's the change in temperature. So we already know A. Don't forget, yesterday when we related this to growth or to decay, we said this value stands for initial. This A, this term A here stands for initial. Remember that. So this is for saying temperature change now. The initial temperature is now 40 degrees. Now, the surrounding temperature, what's the surrounding temperature? The surrounding temperature is 32. So T ambient equals to 32. Is that clear? So I will now substitute 32 for T ambient, 40 for A. So T minus 32 equals 40 e raised to power minus kt. And that means T equals 32 plus 40 e raised to power minus kt. So we'll have our model to that extent. So let me just tag this equation 1 for easy reference. Now, the question goes further to say that after half a minute, the thermometer reads 50 degrees Celsius. After half a minute, what does that mean? When T, small letter t, time equals to 1 over 2, capital T equals to 50 degrees Celsius. That's what it means. So substitute that in 1. So when you substitute that in 1, you have 50 equals 32 plus 40 e raised to power minus k times half. And that will mean 50 minus 32. 50 minus 32 will give us what? I think that should be 18.
18.
Equals 40 e raised to power minus 1 over 2k. Make e the subject, e raised to power minus 1 over 2k will now be 18 over 40, which is e raised to power minus 1 over 2k equals 0.45 when you divide that. So take ln of both sides. Ln e raised to power minus 1 over 2k equals ln 0.45. And that will be minus 1 over 2k equals ln 0.45 will give us minus 0.7985. And of course, you know that minus will cancel minus. So k will now be 2 times 0.7985. That will give us 1.597, which you can approximately say 1.60. 1.60. So using that condition, that is, when time is 0.5 minutes, the temperature reads, the thermometer reads 50 degrees. So that has afforded us to get the value of K. Do you get that now? So which you now substitute back into 1.
Yeah.
So yeah, please quickly write this. So when you're through, let me know.
Okay, sir. Okay, done, sir.
Okay. So the second part, or question 2 rather, that one is trivial. You are asked to show that differential equation y prime equals s squared y minus y over y plus 1 is separable. So, and of course, indeed is separable if you look at it closely. So this implies that dy ds equals s squared minus 1 y over y plus 1. What have I done there?
Yeah.
I factored out y in the numerator.
Yes, sir.
So because I factored out y in the numerator, I can easily just rearrange it this way. Dy ds equals y over y plus 1 into s squared minus 1. So this is function of y, this is function of x. So this function of y, we go and make dy. Why this function of x, we go with ds. So at this point, I can separate the variables. So this y over y plus 1 will go to the other side to become y plus 1 over y dy equals ds will go and meet s squared minus 1 ds. So you have that.
Yeah.
So I can, the left-hand side here, the best thing to do is to divide each term in the numerator by y.
Okay.
The thing is that if you are thinking of the techniques of integration to use, probably you want to think of integration of the form f prime over f, which will not work here.
Yeah.
The best thing is to divide each term in the numerator first, so that you can see what will happen. So when you do that, you have 1 plus 1 over y dy equals s squared minus 1 ds. So you can now take the integral of both sides, which will give you integral of 1 plus 1 over y dy equals integral of s squared minus 1 ds.
Yeah.
Now quickly write this, because the thing that's giving me notice that we have 10 minutes left. Quickly write that. Separating the integral. So if you separate the integral, you have integral of dy, that's like opening brackets, plus integral of 1 over y dy equals integral of s squared ds minus integral of ds. So integral of dy is y. Integral of 1 over y dy, that would be what?
Ln y.
That's ln y.
Yes, sir.
Equals integrate x raised to power 3. That's 1 over 3 s
Times x raised to power 3. Yeah,
minus x plus c.
Okay.
You get that now?
Yes, sir.
Now, I think we are given condition to use. Yes,
Yeah.
solve it with the initial value y of 3 equals 1. So we now use y of 3 equals 1, which simply means when s is 3, y is 1. So y 1 plus ln 1 equals 1 over 3 into 3 raised to power 3 minus 3 plus c. Then 1 is 0. So you have 1 equals 3 raised to power 3 is 27, divided by 3, 9, minus 3 plus c equals, so 9 minus 3 is 6.
Yeah.
1 minus 6 minus 5. So c equals minus 5.
Okay.
So you can quickly write that. And that would mean that y plus ln y equals 1 over 3 x raised to the power of 3 minus x minus 5. That's our final answer. Let me just carve it out this way. Yeah. So after obtaining c equals to minus 5, now write this quickly.
Okay.